Hi everyone, welcome back. Today we are going to study SVM, Support Vector Machine, in very calm and visual way. No heavy maths, no scary words. We'll understand three things only: safe separation and margin and support vectors. Alright, look at these two pictures. Two groups, blue and red one. Think of them as two categories, maybe spam versus not spam or cats versus dogs. Our first goal is simple. Draw a line that separates them. But SVM is not satisfied with any separate line. SVM just wants a line that feels safe, a line that still works even if the data it changes little. So please keep one phrase in mind: SVM equals to safe separation. Quick check. If you had drawn a line here, you would draw it very close to points or keep some spaces. Real data is never perfect. Two things happen all the time. First, noise. Measurements are off bit. And second, new samples. Tomorrow's data looks slightly different. And so if our line is too tight or too close to points, then small wiggle can flip the predictions. A point that was on the correct side may jump to the wrong side. So SVM is solving this bigger problem. How we can draw a boundary that stays stable under small changes. Now comes SVM's biggest idea, maximum margin. SVM says, don't just separate two classes, separate them with the largest safety gap possible. That safety gap is called the margin. So SVM chooses the line that leaves the most empty space between two groups. Quick check. If you are driving, what would you prefer? A narrow divider or wide divider? Same idea here. Let's make margins super clear. Imagine there is a boundary line in the middle and now two more lines to draw, one on each side, like a safety corridor. This corridor is the margin area. Now compare these two situations. One side the margin is tiny, and that means one small shift in data can break our separation. And on other side, if the margin is wide, that means the boundary has breathing space. So wide margin means more stable prediction, less sensitive to tiny changes, better performance on unseen data. So SVM picks the boundary that feels more centered. Now here's the surprising part. Even if there is like 10,000 points, SVM doesn't not going to treat all the points equally. SVM cares the most about the points that are closest to the margin, because those points are going to decide the limit how wide the margin can be. This closest point known as support vectors. Simple meaning, support vectors are the points that support the boundary. If we move this point, the boundary can change. Let's use a very easy analogy. Imagine each point as a peg on board. Now stretch the rubber band between the two groups. Each pegs affect the rubber band shape. Not the pegs deep inside, only pegs on the outer edge and the one band touches. Those outer pegs are like support vectors. They decide the final boundary. If I move far away a peg, will band change? Not much. If edge back, it will change the bend. Yes, definitely. So, what does SVM do? So, after hearing from data, SVM gives us two things. First, a boundary line. Second, a margin around it. Then the prediction is simple. For a new point, SVM asks, which side of the boundary are you on? If you are on this side, class A, if you are on other side, class B, that's why SVM feels very clean. It's like a smart boundary, safe gap, and simple side check. Where do people use SVM? SVM is a strong choice when your data is not extremely huge. Features are meaningful and you want a solid and stable classifier. Example, if we mention, it's like spam detection, text classification, some image feature classification, some bio or tabular data tasks. Where do people use SVM? SVM is a strong choice when your data is not extremely huge. Features are meaningful. And so let's close it with a big picture. First, SVM is about safe separation. Second, it chooses the boundary with maximum margin, the biggest safety gap. And third, the boundary is decided by few closest point, that is known as support vectors. So that's it. If you understand these 3 points, you already understand the heart of SVM. Thank you so much.